Well, especially when
How you
you're
doing?
doing all right.
A
little less graceful. Right.
He just
I'm ready to go.
Okay. Davey's ready. All right, we're going to kick off, and as we present, by all means, feel free to get more soda or pizza if you're hungry. Don't be bashful about being polite or whatever, because I'll be back there. So anyway, yeah, welcome again to, this is the third event we've had for the Rchain Seattle area. And we'd like to thank our host, Perkins Cooley, for offering this space for us. Wonderful. Greg Meredith is a member, as he likes to say, of the Rchain Cooperative, but he's also the president of Rchain Cooperative, but he's a very humble guy, and he'll be doing the bulk of the presentation, talking about the vision of Rchain, and a lot about the why of Rchain, and then also some of the tech, obviously. And myself, I'm going to just have a bit of conversation after that about what we're doing on Rchain Holdings and to build out the ecosystem of supporting tools and early applications and to foster that development as we launch. And as we go through the presentation, we'll be talking some about milestones and schedules, what we've been up to, where we're at, and what's coming next as well. I thought we would start by just doing around the room introductions. We don't want to drone on and on tonight. I really would love for a lot of Q&A at the end and even a bit of social interaction. I think these kinds of meetups are very exciting because a lot of like-minded folks want to learn about blockchains in general, want to learn about Rchain specifically, and so forth. And those are very valuable conversations we want to allow time for. So let's do a quick round the room. Evan?
I'm Evan Jensen. I guess I'm Rchain's counsel. Excited to see a lot of people here, and a lot of people who've been here before. Nice to see you all.
Greg Meredith, I guess president of Rchain.
You are. Lawrence Flair, I'm the technical evangelist for Rchain.
Shingai Thornton, doing a bit of blog writing and product research with Rchain.
Brandon Rapp, it's my first cryptocurrency meetup, and I'm very interested in Rchain. Heard about that at an airport.
Seth Wolfhard, it's my first meetup as well. Yeah, I'm in this content for upcoming ICO service.
Bill Barclay, I'm a commercial banker with Columbia Bank.
Spencer Barclay, in Rchain.
Hey, Christina Bruce, I'm also just curious.
Daniel Rchain, I am
Joshua Rchain, I'm managing director of Ustream, which is an agency up here in Seattle, and we're doing some work for some blockchain companies, and I've tripped over to being an advisor on the marketing side for a couple of them. So generally interested, really eager to see blockchain be a mainstream foundation for technology implementation and making apps in the world.
Hi, I'm Glenn Braun, and I've been a software developer. I've been researching identity related to blockchain.
I'm Brian Lockhart. I'm on the engineering team at Tableau Software. I'm here personal and professional interest in blockchain.
I'm John Mimani. I'm a EIR at Federal Arlington Labs and really interested in blockchain.
I'm Andrea Louie, Martin Davis, the outside counsel for Rchain.
Greg Geis, I'm with Auto Capital, and working on the fundraising efforts for Rchain in the future.
Steve Curiaga, Auto Capital, same. David Auto Capital, and Martin Davis.
Hi, I'm Jonathan Kim. I'm a law student and some associate foster brother at Golden State.
I'm Keithley Tompkins. I'm from Kingsburg International Trust Company, and I've been researching.
Phil Keller, innovation strategist and entrepreneur, and I'm helping Evan put together a blockchain business hackathon.
Nikhil, I'm master graduate of 3 months.
Michael Cherry. I'm an attorney that works with startups and interested in the blockchain.
My name is Navneet Suman, and I'm blockchain enthusiast and involved with Rchain.
Michael Roop, I'm a mergers and acquisition specialist.
I'm Devin Parada. I work as a business development representative for CoinMe, local startup.
I'm Charles Fitzgerald. I'm fascinated by Will County.
My name is Carrie Collins, and I am a real estate investor and sales as well in multifamily and development. So when you guys make all your millions, you want to invest in something outside of blockchain and hard assets, you know who to talk to.
My name is Christopher Watts, and I'm proud to say I will be developing Rchain's communication layer for them.
Yay, Chris. All right. Well, with that, I'm gonna just launch into things. As Ed said, let's keep this informal. So if you got a question, just ping me. All right, don't be shy. Let's have some fun here.
So are you on the Zoom channel so that we can record?
I can be.
Could you please?
Yeah, sure.
Get your slides along with. Who's recording on Zoom? Shingai is. Cool. Thank you.
That means in order to do that, I have to be on the network. So last time I tried to get on the network, I had a problem.
Yeah, I just rebooted the Wi-Fi password for purpose of guest Wi-Fi is Delaware with a capital D.
Delaware with a capital D. Hang on a second.
Everyone. I'm having trouble connecting this stuff.
Last time I was here, it did this and never even prompted me for a password.
Yeah, so if we can't.
Yeah, so I'm gonna not do that.
Okay, thanks for trying.
No worries. Okay. So apologies for the pagination of the slides. There's a new version of OmniGraffle that still hasn't got all the kinks worked out. But I'm gonna talk a little bit about the why of Rchain in particular, and the context for what we're doing. So I'm just going to be blunt about this. There's not a lot of doubt climate change is real, and we're going to have to move at a really, really fast pace if we're going to coordinate ourselves to be able to meet the oncoming changes. And the current coordination technology, whether it's the financial infrastructure or the governmental infrastructure or even the social networks, is just not fast enough. And so we need new mechanisms. So I'm going to talk to you a little bit about those mechanisms as a means of generating test cases for our up and coming consensus algorithms. So I like to solve several problems all at once. Yeah?
Could you talk a little bit louder?
Or grab the mic, maybe.
Yeah, sure.
Is the mic hot?
It says that it's on. Is it on? It doesn't sound like it's on.
No.
What's the point? Hello.
No.
Booyah. Booyah. Okay. I can just talk louder. And maybe eventually. Oh, did I hear something?
No.
No? Okay. All right. Project. I will project. Okay. So, Charles might know this. Back when I was suggesting to use the mobile process calculator in Microsoft for the BizTalk process orchestration, which is the first enterprise and arguably internet scale smart contracting technology. The executives would tell me, "Oh, this stuff is too complicated," and so I would shame them by going into local middle schools and teach 13 and 14-year-olds how to do pi calculus. And I would then say, hey, if they can get it, you can get it. And one of the things that we were talking about when we were talking was concurrency and AI. AI is a hot topic these days. And I had this kind of weird idea. What if you did an AI for a chess game where you just had a bot for a pawn and another bot for a pawn, and the intelligence emerged, right? So there wasn't actually white player. There were all these bots that were coordinating and communicating. And they didn't really know about the whole game. They just knew their particular role and their coordination. But somehow out of this grew this other organizational intelligence, right? And the question was, could I even do that? Could I even approach that problem? So this was in 2012, so 15 years ago. I had this kind of weird thought fly by, and I just noted it down. Okay, that's an interesting weird thought. And then about a month ago, I was thinking, actually I was packing up some music here, and I was thinking, how am I going to test Casper, our new consensus algorithm? And I had another thought fly by, and that thought was, I think I can use Casper to build that weird, crazy AI idea. So let's see if we can do that. That was the thought. And I kind of want to contrast, to set the stage, to contrast these weird, crazy ideas, to set the stage and to connect the dots between my opening statements and these statements. I want to contrast the conversation between the individual and the organizational intelligence that we all know, right? Everybody has had this experience. You're on the phone with some organizational entity, some institution, some bank, some hospital, some governmental agency. You're on the phone. Why? Well, because the website doesn't do what you need it to do. It doesn't handle your case. And you've just navigated the phone tree about 10 levels deep, dutifully supplying all the information. And then you get in touch with an individual who, for some reason, doesn't have any of the information that the phone system collected for you and is not actually empowered to handle your case. And so you're going to sideways navigate through the organization a little bit, and then maybe you're on the phone for another 20 minutes, and then the call drops. Okay, so this is experiences. How many people have had an experience like this? Okay, so everybody understands what I'm talking about, right? And I would argue that this is the dialogue right now that we commonly experience between organizational intelligence and individual intelligence. And if that's the dialogue, and we have these oncoming environmental pressures, we're screwed, right? So we got to have more effective organizational intelligence. We got to be able to consent to and participate in more effective organizational intelligence. Awesome. Okay, so if we get that idea, the next question is, well, can we just look around in our common experience and say, have we ever seen more effective organizational intelligence? And I would say, yes, you have. Lots and lots of times. Most people pay to go see musical ensembles because they're watching people. They enjoy the experience of a musical ensemble working as an ensemble, right? Whether it's an orchestra, which is conducted by one single conductor and a score driven in that way, like Western music, or it's a jazz ensemble. And it's not so much a centralized top-down control structure, but it's a more egalitarian, more flowy kind of control structure. So we've seen that. We actually know what it feels like to participate in harmony that's real. You've actually had this taste. That's why people go pay money for that. And there are lots of other examples. I was just talking with Kenny Rowe today, and he said, that's another reason why we go watch sport. We love to see people working in concert together, and we know that it's possible. So this is not some crazy, strange sci-fi idea. It's something that's a part of our common everyday experience. So what I want to do is I want to see if our consensus, I'm going to employ our consensus algorithm in a little problem. And the problem is to play a game. Okay? So what I'd like it to do, just as I said before, is to play as one player against, let's say, human agency. Okay? And we want it to play in such a way that this organizational agency, whether it's an agent of an organization of bots, or an organization of humans, or a mixture, right? It needs to appear to opponents. So without loss of generality, well, this is really fun here. Keeps me on my toes. Without loss of generality, it needs to appear as if it's a human player, right? As if it's at least, if not a human player, then at least it's a central entity. It's an organization that behaves as if it had individual intelligence. So here's kind of where we are, and this is going to be not only a test for consensus, but hopefully it's going to set the stage for us to begin to think about what it might be like to organize ourselves more effectively, to be agile enough as an organization that we can play a game. Right? That's very different than the phone tree experience. Okay. So I think I've said just about everything up to here. Okay, so now, in order to explain this idea, I need a little bit of background for folks. So I don't have the background in the slides, so I'll just swing it. I've been talking about this with Vitalik and Vlad for over 2 years now. I should be able to wing it. Hopefully I can wing it. So a lot of people have probably heard of proof of work as a kind of decentralized consensus algorithm. And maybe fewer people in the room have heard of proof of stake. Proof of work, the way I like to think about proof of work is the same way I think about HTTP. HTTP is stupid. It's one of the stupidest protocols ever designed. It's not possible for a computer scientist, even an undergrad computer scientist, to have designed HTTP. It took a physicist and no disparagement on physicists, actually. The thing was, they're not indoctrinated to the way of thinking that a computer scientist is indoctrinated, right? The protocol, in order to succeed, had to be stupid. That's the thing that was really, because at the time, no sysadmin was going to punch a hole in their firewall if it had been a really clever protocol. It needed to be stupid to penetrate. It's just like the complexity of certain viruses. They need to be low in order to do their job. So the same thing is true about proof of work in the Bitcoin blockchain. It was necessary in order to be the kind of pedagogical instrument to open the door. Like once people saw what you could do, like those of us who've been around long enough to know when the internet was called the DARPANET, maybe kind of saw what was going to happen. In fact, many of us working at MCC, where I work, the Research Lab at MCC, saw this coming about 25 years in advance. But in order to cross the chasm, the imagination of many other kinds of people, apart from computer scientists and propeller heads, needed to be sparked. And that's what the World Wide Web did, right? And that's what the stupid HTTP protocol did. And we don't run HTTP 1.0. We don't even run HTTP 1.1 really, right? Most of HTTP is built out of lots of little mini protocols that have to do with streaming and other kinds of things. And so a similar kind of thing has had to happen with respect to this new family of consensus protocols. Okay, so people can grasp proof of work because it's so simple, but kind of because it's so simple, it's not really scalable in the same way that HTTP 1.0 was not really actually scalable. And why you have to do these kind of side protocols in order to do a realistic computation across the internet. But what happened was people got this idea that you could have a decentralized means to replicate data. So you didn't have to have a master-slave relationship in order to get agreement across a bunch of nodes about what data was at each node, right? And once people saw, I can give up data consistency right now and have eventual data consistency later for availability. That's effectively the class of trade-offs that we're doing in this space. And so proof of stake, it takes this idea and extends it a little bit further. And the rough idea is that, okay, just be black for a while. Okay, so in order to make this scale, the thought is we replace miners with validators. We're validating blocks, transactions, and they play a central role in the same way that miners play a central role. And so so we need to incentivize their service. So there's a set of fees that get delivered to the validators for the work that they do. However, in order to make sure that they're engaged in the protocol in a reasonably fair and honest way, we do a couple of things. One, it's a pay-to-play protocol. So it's not just like a poker game. You got to ante up something in order to just be in the game. Okay. The other thing is that there's a set of rewards and punishments that are associated with staying in the game. So if a validator does something wonky, like for example, saying to one validator, hey, these are the transactions that I think should go in the block, and saying to another validator, hey, I think it's these transactions, and they're different, right? And in particular, there's a double spend. Then in the presence of a network that has a great communications layer, right, in which everybody is whispering to everybody else, eventually that equivocation is going to be found out, right? And as a result, the rest of the community, or at least a large percentage of the community, it will be incentivized to slash the stake that the validator has put up. And so what happens over time is that the only validators left standing over chunks, periodic chunks of play, is that the good validators survive, unless they're funded by some extremely deep-pocketed cartel, for example. Okay, and the other thing about these kinds of protocols is if we do them well, then we kind of can know what the characteristics are. How many players have to be in a really evil cartel before things start to go bad. And we can, with the mathematics that we're employing, we can actually get a very, very much more fine-grained view on this than we had with the previous generation of distributed consensus protocols. So that's kind of what you need to know to understand Casper. Okay, and so now what we're gonna suggest is that we have a community of agents, whether they're humans or other kinds of agents, that are concerned with one resource, right? That resource could be a pawn, it could also be a neighborhood, lots of other things. I'm trying to be suggestive here, not being very subtle at it. And there's in our first approximation, we're going to say there's one validator associated with that resource. In Rchain, we can have lots of validators associated with that resource. So there's a little sub community of the overarching community that is worried about, you know, pawn 1, another one that's worried about pawn 2, and so on out to pawn 8. There's a sub community worried about knight 1, another sub community worried about knight 2, and so on. Now, how do we get them? So notice that each validator in this setup has got to put up a certain amount of stake. And that stake distribution is going to play a critical role in this setup. Okay? So the thing that we can do with the existing setup is we can play the reverse of the game that was played by the community 15 months back or so, and not argue about the block size. We'll say the block size is exactly one transaction. And what does that do? That forces there to be exactly one move that's selected by the whole aggregated community, right? So all the players that are controlling the first pawn, they're making suggestions and making proposals, right, to the validator. And all the players that are trying to jockey for how to move the queen, they're making suggestions, and only one of those is actually going to go through, right? So now we actually have a mechanism by which all of these participants roll up, just because we have a consensus mechanism. Is that making sense? Are people following the idea? Cool. So I just got some pictures just to make sure that everyone's intuitions are in sync, right? So we've got a bunch of clients, all of whom are making some proposals for the pawn, and that rolls up to a validator or two or three. Likewise for the knight. Okay, and we just said that if the block size is 1, this guarantees that the validator is big as the move. Okay, now here's something really interesting about this approach. The block size allows the 2 players to alternate, right? So that, you know, black can take a move, white can take a move, black can take a move. So that works out. But the other thing that's interesting is that if this is really a consensus algorithm, then black player can say to white player, show me the proof of the consensus that gave rise to this move. So this is a new thought, right? This is something very different than what we've been seeing, right? Because first of all, in terms of the existing Casper algorithms, in particular the algorithms that Vlad and I have been talking about, just a little bit more background. When the messages flow, what they come with is justifications. So you can think about it this way. In a particular protocol that maybe has a little bit of state, the first message to a server, it's always justified, right? Because the server's always they're ready to, you know, like if you walk up to Amazon.com, right? You know, it's got to have the front door open to let customers in. But once the customer request is in, then the next request has got to be justified by some response to the server, right? And then as they get deeper and deeper into the dialogue, each request as a part of the dialogue is justified by the previous chunk of the protocol. So we're keeping these justifications as a part of making sure that the protocol players are doing the validators are doing the right thing. So what that means is once you've achieved consensus, you have these little traces of message flows, right? That's a part of the protocol. We're keeping these little snapshots of message flows, and that's proof of consensus.
So not to distract, but it brings up the question: where's the ownership of the rules? That you're going to prove, right? Because it's really important.
That's very good. That's very, very good. And I'm going to address that in subsequent slides. And I love that question. That's a very good question. Of course, when I'm thinking of just as to increase the narrative tension, you know, put that thought to one side, and I'm just going to say, as a test framework, just to give to my test organization, if this thing doesn't, you know, play fast enough, if the opponent, if black player gets bored and says, this is boring, right? Literally, as a human being, if a human being times out, this consensus algorithm is certainly not fast enough, right? I mean, even, you know, like certainly at 2 transactions per second, that's not fast enough. Even at 15 transactions per second, this is not fast. Sound, you know, familiar numbers? Right? This has got to be much closer to, I don't know, 40,000 transactions per second, something like that. So this is kind of the framework that I'm thinking when I want to motivate our test organization. But this other idea I think is really interesting for a couple of different reasons. One is it becomes too expensive for someone to maintain a sock puppet network, right? If black player keeps saying, proof of consensus, please, proof of consensus, please, proof of consensus, please, each one of those message flows involved a bunch of transaction fees that were all recorded on the blockchain. So over the course of a game like this, it becomes, or a much more interesting protocol than just a game of chess, it becomes much too expensive for someone who's pretending to be an organizational entity to maintain that facade. Okay, so this is new. This is a new idea, right? You can literally ask, show me that you're a real organization. And if the consensus protocol is working, it can provide you that. The other thing that this does, again, switching hats from you know, concerned citizen about the state of the world to nerdy computer scientist. One of the things that's really weird about deep learning is that it can't explain why. It can't tell you why it classified this painting as a Van Gogh and that one motifs, right? It just, you know, learns some weights and some cells. This one can explain why. That very same proof of organizational identity tells you exactly what the reason was for this particular consensus. So this is a different way of thinking about organizational intelligence entirely. Okay, and just for fun, I want to relate it. I don't know, you know, back in the 90s, Kevin Kelly wrote this beautiful book called Out of Control, in which he argued for the value of decentralization, like, you know, a full 15, 20 years before we're at this point. Anybody read it? Awesome. Of course you did. Okay. So one of the findings that he reports, and this ends up showing up in toy stores and all kinds of other things, is that when robotics made the shift, for at least for locomotive control, from a centralized mechanism out to a decentralized mechanism, where you made ant robots where the legs were smarter, right, and the central body was just the message passing hub amongst these relatively not too smart legs. Then you got a much better increase in the robustness and stability of the locomotion of those kinds of robots. And all I'm doing is just taking those very same principles and applying them. Right? That's what this is all about. That's what the decentralization movement is about, is pushing the control out to the leaves, right? Which is effectively what we're going to need to do in order to be able to move fast enough to address the changes that are coming. Okay, so we've kind of talked about some of these things. Now I want to hammer home something that's really important, which is that in Rchain, we can think of each one of these resources here as effectively its own little mini blockchain, using the namespace mechanism of Rchain. And then cross namespace mechanisms, it can be utilized to do the kind of aggregated rollup. So this is a powerful idea. So this is not the same as sharding, because sharding is n levels deep. Like in Vitalik's recent proposals, it's 2 levels deep, right? I mean, that doesn't even work for DNS. So yeah. So what this does is it gives you a compositional model, which is as many levels deep as you need to go. And we think that that's important because we think that there are going to be lots of different kinds of resources that you want to put a blockchain next to or in front of or something like that, right? So that blockchain becomes a kind of on-chain interface / oracle, right, for particular kinds of resources.
I apologize.
No worries. It was nice.
It's a heart monitor, and I'm sorry.
You okay?
I'm okay, but I need to not disturb the crowd. Excuse me.
All right. So, and there are lots of things that are related to this particular way of thinking that you can both relate to the game metaphor, but also to testing Casper. So, and this corresponds to looking at different games and different approaches. So in particular, one of the things that we want to be able to do is we want to be able to reason about what happens when you have network partitions, right? So there's some kind of disconnect amongst the validators and what happens when they come back online. At least within the Rchain versions of Casper, these are kind of, they're treated uniformly. And we can talk about that in more detail. The other thing that's really super important in this kind of protocol has to do with when do validators come into the game, right? So if you think about a poker game, right? When can someone join in and grab a hand? So with respect to the blockchain, you're going to have an initial set of validators that are vetted in the Genesis block. And so that's how you get the whole thing, a proof of stake, a validator set off the ground, right? And then once they're in, then you have two things that you have to worry about. You have to worry about A, when can a validator cash out? Okay, I've done this for a year and a half. I got all the fees I want. I don't want to do this anymore because it means I have to have hardware online nonstop, 24 hours a day, right? And now I'm ready to unplug that machine, right? And I want to do that because I've collected enough fees for I've done my time, done my service, right? So that's unbonding. And the other part of this picture that's important to the Casper protocol is bonding. How do I get to be a validator? And this turns out to be a really critical question, because if you have a cartel of validators who are maybe a little shady and maybe they want to stay in control, then when you're trying to bond a validator, who's validating those bonding requests? That cartel. So these are the kinds of questions that Vitalik and Vlad and I think about, and there's some interesting answers to those. Like, for example, with respect to that one, you can have a lot of transactions be blind transactions, so you don't see the content. So you don't know that it's a bonding transaction. So these are some kinds of things that we think about. Another piece of the protocol, and so with respect to the games, right? When a piece goes off the board and never comes back on, that's cashing out, right? When a pawn goes off the board and comes back on as a queen, right? That it can be thought of as network failure, right? So again, I'm trying to think of these nice concrete, so the piece went off and came back, right? So I'm trying to think about these kinds of game events as providing a nice, crisp, concrete model that our testers can be thinking about when they're writing out tests for Casper. Okay, and at the same time, I'm trying to think about this in a larger scheme. Note that in chess, you never go past the 32 pieces, right? You start with 32 pieces on the board, and then either some of them get removed, right, and maybe some come back on, but you never get past 32. If you're playing Go, then more and more pieces get added to the board, up to at any one time, no more than 361, 19 by 19, right? Did I get the math right? That's kind of important, because as we're talking about scaling out Casper, we want to be able to, or scaling out the consensus protocol, we want to be able to add nodes. And so we have to be able to test this behavior, right? So these different kinds of games give us a different way of thinking about these. All right. So the next piece of the puzzle, and I'm hoping people are kind of grasping what I'm driving at here, is this doesn't do very good look ahead, right? This particular way of organizing this group of players into one player, it doesn't do a look ahead, right? They're all kind of duking it out, right? And depending upon the stake distribution across the validators, that's going to determine essentially who wins. Does that make sense? Is everyone grasping that idea? So if validators that hold more stake essentially have more sway as to which transaction gets in, right? So if the validator that's associated with the king, or the group of validators associated with the king, has the most stake, which
are they seated that way from the beginning, or is that part of the rules discussion?
They pay to play up front, right? So that gives you an initial distribution. Yeah, and then over time the play is going to change. Yeah, exactly. Okay, so you're right. There is a little bit of a feedback loop, right? So there's a little bit of leeway, but this is not a particularly smart player, right? So a human player, a chess master, could probably beat this pretty quickly, right?
It's a question.
Yeah.
Depending on the move, sometimes even moving a pawn may be more important than moving a queen, right?
How do they?
So how does it relate to the bonding? I mean, even though what you suggested, the king, whoever the validator bonders are, they have more stake.
Yes, and that's exactly what I was saying. What I was saying is that in the initial framework that we thought of as just a very, very tinker toy-like model, the only intelligence of the white player organization is the distribution of stake. So as you twist the dial on that distribution of stake, you're going to get a different play profile, right? Does that answer your question? Yeah. Sweet. Okay. So let's consider an alternative. And then notice that one of the things that's kind of not ideal in this particular setup is that the intelligence or the notion, the understanding of the rules of the game is more in the validators. And we don't want that. The validators their job should just be, providing consensus. So what we want is to shift the mechanism design just a little bit. Okay, so what we'd like to do then is imagine that we tokenize this a little bit. Let's just use the mechanisms that we've had before. And again, I'm not suggesting that this is the only way to do it. I'm trying to get you to think about this kind of technology as a means of designing coordination mechanisms for people on the planet. Okay? Right? We should, once we have the ability to press a button and mint a currency, we have a much more agile way to coordinate ourselves. Okay? So you can imagine that there's a trade-off. And the trade-off is say versus tokens, right? The white player organization has got to make a move, right? So it's incentivized to make a move. So every party that has a say in what the move is, they've got something of value, right? They've got a vote, right? And in this particular, if we start with consensus as the model, and this is not the consensus developed by Casper, this is the consensus of that organization. If consensus is the model, if not everybody says, yeah, I'm in it, then you have to have some mechanism of mediating that, right? So far, we had a silly mechanism, more or less, to mediate that. Now we're talking about trying to make that a more nuanced mechanism. So what you can do is you can give a trade-off between tokens and say. So what you say, so the mechanism would be giving up tokens. Giving tokens to someone else means having more say. So you're essentially buying their say. So the paupers have the most say, in some sense. Okay, if you're following. Okay, or the other way of saying it is that tokens become deferred ability to hold a position. It's deferred choice. Okay, so then that's just within a particular piece's subcommunity. Now you can imagine rolling that up, and you can either have the same token, right? So between the pawn 1 and pawn 2, right? Let's say that they've come to a decision about who in pawn 1's community has the say, right? There was a lot of transactions back and forth, and they settled to a fixed point or a steady state where this little cartel here has the say about the move. And they're all in agreement about that, about what they want to say, but they've got the feather, right? They can say. But now that group has to coordinate with the next group, pawn 2, right? And now they can either use the same token or they can use a community token, right? And so now you can marketize this whole aggregation, this whole roll up of the community into a single move. Is this making sense? Are people following along?
But
go ahead.
Isn't it that they are all competing though?
How are they incented to cooperate?
Yeah. They're incented to cooperate because unless they come together for a move, they don't get to play in the game. Right, so the game goes away. So that's the final step here, and I'm glad we set it up, right? So by the way, of course, in such a system, I had to put this line in, right? I have to draw this line. In such a system as this, the king wants to be a pauper, right? The king wants to have the most say because if the king dies, then you don't keep playing. And in fact, the staying in the game is the incentivization, and that relates to a much the final piece of the puzzle, so to speak, which is the response of the opponent. So if black player, without loss of generality, if black player is the opponent, right? Then what we want is for the objective characteristics of that response to somehow be tokenized. So now notice what happens at the boundary here. This is very interesting. What happens at the boundaries, if the opponent doesn't tokenize, then then all of the tokenization view of the world has to live entirely in the white player organization. Okay? And so there, you would have to then come up with a measure of the quality of the move that was made. And part of that measure is going to be based upon the responsive opponent, and part of that measure is going to be things like the position on the board, like do we still have Sente or initiative? Sorry, I'm more of a go player than
Question, if black and white are playing game, so white, how does it matter black needs to verify whether it's a legit move or not? And the end result of the game is I want to win, right? So I don't care how you move as long as you're moving the right boxes, I'm okay with that.
Yeah.
So why should I care about how they validate those?
Yeah. So the important thing there is that you have a set of legal transactions. Right. Right. And once you have a set of legal transactions, right, which are then, and that part is encoded in the validator, right? We know what a legal transaction is. So that part is declared up front. Okay. So now notice that something else happens, and this is kind of where I want to dovetail things a little bit. Notice that something else happens if it's not bots, if it's human players. So if the human players can all see, even if they're only just concerned with that one pawn, and that's the restricted, or that one knight, that's their restricted realm of responsibility. If they can see the whole board, that changes the way they play, right? And we've seen this before, right? That's what I've been trying to talk about when I refer to music, right? When the human participants can get feedback on the whole system, which you can when you're hearing the whole piece, right? The guitarist is listening to the bass player and the drummer and the singer, right? When you can get feedback on the whole picture, it changes how you coordinate. It actually changes the way in which you coordinate. Right? So that's really critical to the kind of thing that we want to be able to do if we are going to coordinate ourselves with respect to climate change. Right? We need to be able to, all of us, simultaneously have a whole picture. Whether it's a whole picture of the blockchain, which you can have right now, right? Or it's a whole picture of what's happening with respect to the climate, while being able to act locally and coordinate with others in a local fashion, right? And that's the why of Rchain. Is that making sense to people? That's the why. Now, I've given several talks here about the how. So I mean, I can wing that. We can do that. But what I would like to do is just to talk a little bit about the win. Okay. So the win is that in the next 9 to 12 months we'll be releasing Mercury. And so what do you get with Mercury? Mercury is designed to enable the kind of hello world application that you expect with a blockchain. So in particular, you should be able to mint a token, create a wallet, and exchange tokens from wallet to wallet across the network. What kind of network? A network of hundreds, mid-hundreds of nodes. That's what we're proposing for Mercury at this time. And that should be happening roughly in the time frame of 9 to 12 months. That's our aim. Now, concomitant with that, there are a bunch of other timelines that are impacting this or related to this. One is that we're trying to make sure that we have a bunch of applications that drop along with that or at least the requirements gathering for those applications. Right? So, so the application of making a token in a wallet is not much more than what Bitcoin can do. So you haven't really gone very meta. You haven't really provided a lot of programmability if all you can do is stamp out lots of copies of the Bitcoin network. That isn't very interesting, at least at this juncture, because we've kind of seen that you can do that. What's necessary is to begin to have other kinds of observables to see that we're going to be able to move at the scale that we've kind of hinted at here, right? So we're interested in a collection of applications, one of which is very meta, very dog foody, and that is developer tools. So the aim is to have a very significant blockchain-based developer tool solution shortly after Mercury comes out, like very shortly after Mercury comes out, right? So here's the kind of vision that you should be thinking about. Even in the compiler chain from source code, what kind of source code? Well, it's in our contracting language called Rchain, and that's based upon Charles's favorite calculus.
Well, I still haven't made the move from pi to rho.
Oh!
I thought that's what you were going to cover.
No. I've given that talk a bazillion times. It's all over YouTube, but I can give it again if you want.
I didn't get all the nuance.
Okay, well, I'm happy to give that again. But the source code of Rho language compiles down to an intermediate representation, which is almost exactly Rho calculus. And then out to the bytecode for our virtual machine, which, by the way, you can run today. You can go test our virtual machine today. And you can actually, we have an implementation of an ERC20-like token in Rchain right now, and you can see that compiles down to the Rosette VM and mostly executes. There are some things that we still have to cover, but it mostly executes. So even in that compiler pipeline, there's lots of opportunity for optimization. There's lots of opportunity over time to improve the kind of code that ultimately gets executed. So you could imagine that over time, when you have much more rich and sophisticated applications, applications that might be financial applications, applications that might be network analysis applications, applications that might even be graphics applications, that you might want to plug in special purpose tools there. So in the case of financial applications, you might want to put in, I don't know, Simplex. That's an example. So you can think about a compiler pipeline where the intermediate drops go to the blockchain, and everyone can see what's happened from this step to this step, right? And as a part of getting it through this tool chain, that costs a token. Right, so this is the kind of world, and what that does is that incentivizes tool builders to be able to build tools, right? Or right now, think about the world of IntelliJ, right? IntelliJ has the community edition, which 99.9% of developers use, and then there's the enterprise edition, and what a terrible business model. But IntelliJ is necessary. We need these kinds of really sophisticated tools. We want to have a Rchain plugin in IntelliJ. So we're hoping to provide them with a business model as well as get them on board with having a Rchain plugin. So that's the kind of thing that we want to have drop right away, right after Mercury. There are some other applications, and maybe Ed can talk about those at some point this evening. So I'm going to take a breather here, take the temperature of the room. We can go all night, but questions, comments, thoughts?
I have a question.
Yeah.
So there's been some sort of interesting experiments, almost social experiments with online decision making. For example, Twitch plays Pokemon.
Yeah.
These have not really been very successful as a way for, like, it's not very smart, it's not very intelligent, it's not very fast either, right?
Yeah.
So how is it that this system leads to an intelligent organization that makes decisions smoothly and effectively, when mobs on the internet screaming what they want to do has not really been successful.
Yeah, so I absolutely agree that mobs screaming what they want to do, whether it's on the internet or a rock concert, is probably not going to get done maybe what you set out to do. I do believe that groups of people using market mechanisms and other kinds of mechanisms to design coordination systems absolutely can do a lot better job. So the point here is that we have the substrate to use in the vernacular science the shit out of this, right? That's what this is all about. Is that we have the basic substrate to start designing and tinkering and playing around with, right? I mean, Augur was just the first step in this direction at the blockchain level. I think there's plenty. Well, look, I mean, the point is that the U.S. Constitution argues point blank that collective intelligence is better than individual intelligence. That's what we signed up for when we signed up for democratic principles, right? And so now the question is, how do we make that happen in a way that's effective enough and efficient enough that we can handle the oncoming changes? So that's kind of the hope, is that we have a set of high-level tools that allow us to science this. Does that answer your question? Any other questions?
I'd like to hear more about the potential use case scenarios, like some of the apps you have in mind, like the tool chain incentives. That's a great one.
Oh, cool! I'm glad you like that.
Yeah, let me set up a slide with that on it. So what's interesting is when you, I remember the last conference I was at was in New York at the end of May. There were Consensus 2017 and Token Summit. And then for anyone that is reading about blockchain news, there's so many ideas out there. Just hundreds and hundreds of ideas and hundreds of tokens that are getting launched. But there were thousands of people at these conferences, but there was one particular part that just struck me. It was an academic panel. They were talking about all the practical use cases of blockchain, and one guy stood up there and said, "Look, if we look at today's blockchain, the only practical use case is basically remittances and moving money all over the world, and that's a Bitcoin use case. Everything else is kind of just proof of concept and testing out business cases and so forth." And that gave a lot of people pause in the audience, including myself. And it's like, really? There's nothing else going on? And yet, so maybe there are, but I think that's essentially truthful today. And then, so why is that? Is it because the businesses don't know what they want to build with blockchain? Yes, sometimes that's true. They don't have a full use case or whatever. There's a lot of change management and so forth. Or they're expecting things out of the blockchain that are just well as done with a centralized database, because they're really not talking about moving away from a centralized concept. But for the closer to decentralization that you get, the reason has to do with the transaction throughput, the scalability, the energy to achieve consensus, and those kinds of things are really what's slowing down these blockchain projects from becoming practical and delivering value. And that's exactly the kinds of things that Rchain is aimed to solve. So, long-winded answer to answer your question. There is such a huge number of use cases out there that are good ideas. And when I looked at them and sort of what are the dependencies, right? If you're going to build supply chain management, micro lending, marketplace for services, and so forth, there's some very basic things that we have to get in place first. And these are the same kinds of things that came up around Bitcoin and Ethereum. So great wallets, we have to build that. Time stamping service is a big enabler. it's, for timestamping is basically at the simplest level, it's taking a hash of a digital document, recording the hash of a blockchain to prove it existed at a certain point in time. But that scales, that simple concept scales all the way up to something like DocuSign, which is a huge business, right? Of just making sure that people are signing the right document at the right time in the right order. So even something as simple as timestamping in a wallet with a little bit more and adding a little bit content management on top, all of a sudden you have major businesses. So content management is right up there, where content management in the way that I'm talking about is, you can think it in the simple one is just storing documents like a Dropbox. Okay, then you put versioning in there and all of a sudden you have a decentralized GitHub. And then when you guarantee performance for large content, now you're talking about an edge network like S3 or Akamai or others. And so that becomes really interesting. Then you're that plus monetization, you're enabling things like SoundCloud and that's monetized and so forth. So there's a couple of these very basic capabilities that really enable a bunch of things. Identity is another area, and Glenn has been studying identity and what's the leading practices around identity and blockchain. And especially in banking, business to business, business to consumer, that's involving large sums of transactions that have to comply to regulations. KYC and identity are important. So these are some of the early things we need to put in place. And then once those building blocks are put in place, then we can go on to build, social networks, go on to build marketplaces, go on to build a full music delivery system and ecosystem around so budding artists and other creative content producers can monetize their applications, not to mention supply chain, not to mention financial trading and all of these other kinds of use cases. They all kind of depend on these basic building blocks. So that's what we're going to be focused on first. Yeah, Michael.
In all those examples you gave, can you expand on the supply chain model? This is the one that I've been really trying to wrap my head around, as how does blockchain streamline a supply management problem?
So sometimes I think it's just record keeping and essentially provenance of a particular item. So like shipping containers, let's say two companies are sharing the contents of a shipping container because neither one can fill the shipping container, right? So then the point at which it transfers ownership or the liability for the goods is really interesting, right? If paperwork essentially slows down the movement of that container because the paperwork isn't in order, then you have things rotting on the dock. Okay, so that's probably handled by traditional technology largely. But then you have these interesting things where from one source goes a lot of places. Let's say it's a meat packing plant. Eggs? Pigs, yeah. So where the same source material is going to a lot of places, and it has to be tracked where it goes and what end consumer product it's in. So with sort of an immutable ledger of the ingredients and where it came from and the batches, potentially could be done better on the blockchain.
So I get that from a conceptual level.
Yeah.
I'm trying to get from conceptual level to reality, and that's where I'm really struggling.
Walmart is doing that today with pigs in China. So they want to be able to see, because, sorry.
Please.
There's been a lot of contamination. They want to be able to trace, and it's actually not as, the technology doesn't do a great job because it's a lot of manual handoffs of paperwork of from farm to shipper to the next shipper to the next shipper, then it got on a boat, and trying to figure out where that pig that came from was contaminated or other things. And I talked to about a dozen companies a month and doing something similar with another food processor.
So you hit on exactly what I'm trying to understand.
Okay.
And what I'm trying to understand is, if you have this automated technological contract from A to Z, but you have a system like that that requires a phenomenal amount of human input at every step along the way, then how is blockchain any more efficient than, I'm going to use a crude example, using just an open, smart sheet spreadsheet that said, oh, this container came through here and I parsed it this way, and this way. Now it's next to
or a piece of paper.
Yeah.
That is exactly the point, right? So you can digitize the ownership of where it's coming, and that's what gets stored on the blockchain and then gets handed off over and over again. It's when it's repeatable, that's when it becomes interesting.
And immutable.
Well, immutable, right, that's really important. But in this case, it gives you the traceability so that you can always go backwards in time and look where it came from.
So who trusts your spreadsheet? The person who has the spreadsheet, but does the person next in line trust the spreadsheet? No, right? Unless that spreadsheet is somehow globally visible.
Well, that's why I use the example of smart sheets, because you can just make an open smart sheet and you have your cells locked, you do your task, and then it moves on to the next, right?
That's great. And who's controlling the infrastructure for the open smart sheet? You have to trust them.
Well, okay, well, which now brings up another part that I'm trying to understand from concept to reality, which is, okay, I'm trying to accomplish this thing from A to Z. Let's use the supply chain. And I'm Walmart. Well, who builds it, who runs it, and how do I know that they built it right to implement it? I mean, the trust component, when you take out the monetary Bitcoin stuff, when we're just trying to look at the efficiencies, that's also where I'm struggling on that leap. Because I hear what you're saying, but I actually agree with you even within the blockchain. Like, how do you know that it was even done right and it's...
I'm so glad you asked that question. One of the things that we talk about a lot when we talk about Rchain is that the value of the formal methods, and in particular the way the formal methods is folded into contract developers for ordinary developers, not people who are building a platform, but who are building applications, is that those formal methods give you a mechanism to describe when the thing is correct and to establish amongst the parties involved what correctness means. This is what we were actually trying to get off the ground with BitTalk. There's a whole bunch of codified notions of what supply chain management means. Right? A whole bunch of contractual descriptions of what supply chain management means, and when it is correct to connect this supplier to this provider, right? So that you can check that in fact they have the same set of expectations. And they're really basic things that you might want to check, like the supplier isn't waiting on something that the provider is going to give, and the provider is waiting on the suppliers something that the supplier is going to give to kick the whole thing off. But that's a deadly embrace. That's a deadlock. So that's a really basic kind of thing that you want to do. You also want to be able to check things like you can know for certain that certain kinds of information that's associated with the exchange of these goods does not leak to other parties. So these are the kinds of things that we can record in the formal methods that basically just become types on row-line contracts.
So then next step down in your charts, and again, I'm very keen on the supply channel. Are you still using validators for each step? And what are the validators validating if you're relying on human input or feet on the ground at each stage?
Using validators just for transactions. So it's just for packaging up transactions. Now the important...
So they wouldn't be used in this example?
No.
That makes sense.
Only the extent to which those things are, those kinds of things have to do with transactions that get recorded against the blockchain. So,
okay.
Right. So if a bunch of human interaction results in a bunch of input that gets packaged up as a part of a transaction to update state that's in the blockchain, then somewhere in the whole network there are some validators involved saying those transactions got in.
So within the chain, and forgive me if my vernacular is incorrect because I don't know coding, but within the block or the chain, how does a human interact with it if you have these supply issues where multiple people need to physically participate and plug in their little piece? before we go on to the next step?
So, I mean, the standard application architecture is going to be that there are smart contracts that are associated with the human interaction. They're mediating the human interaction, right? And then those smart contracts will then update a part of the application state.
Right, and every transaction is cryptographically signed by an account or an agent that is permitted to, right? So, so with elliptic curve digital signature algorithm, right? There's a public-private key pair. Keep your private key private and use that for signing messages that can be independently validated that they were signed by your private key. So that basic key pair public key cryptography is a key basis of instilling or providing trust. And then when you combine that with KYC, so that you know the entity that is behind that public address, then that increases the trust.
I think you may have been asking a slightly different question. Correct me if I'm wrong. But you're saying, how do you know that a statement that is being made is true if you're trusting the foot on the ground to actually do the thing? Is that what you're asking?
Well, that's an aspect of it, yeah.
Okay, so on a blockchain, when you sign a transaction and put it in the blockchain, right, you're proving that it was you because only the person who has the private key can sign it and encrypt it correctly, right? So that's only the person who is the foot on the ground can do it. And when you sign a transaction that says, I'm transferring this token to this other address or this other person, the fact that that occurred is what goes into the blockchain as sort of immutable record. Now, the question I think you're sort of following up with that is, well, what if I proof of existence a document that says something that's not true? A validator doesn't check that. The validator is checking, yes, that was put in the blockchain at that time, and this is exactly what the data was.
So
I think he
very
agreed with
specific. Sorry.
No, so what I was saying, that I think his question probably looked for the individual trust rather than blockchain. I think he agrees that blockchain, everybody trusts blockchain, right? So I want to just add to these guys what they're saying. I think one thing you forget about that, blockchains are more decentralized, how it thinks, how people respect to the software. I think that's bigger problem with blockchain solving than all these trust companies. You can get those things with a simple SQL database put in everywhere, everybody enters the data. If I'm entering the wrong data, of course you can't do anything about it, right? So you have to trust them. And whatever your edges are, that if you are involved in one of the edge, if you're entering the false data, then you can't do anything about it, right? So you have software which will help you to enter the correct data correctly. That's one part. So point out the blockchain.
Well, the state of the network also has information in it, right? So this address has this token. If you're doing a supply chain management, I hereby transfer this shipping container to that other company. You can't lie about that. That's not a fact that is possible to lie about. Either you did the transaction and it happened, or it's not in the blockchain and it didn't happen. You can't. That's not the way if you structure it correctly. That's not something that you can lie about. The same way that you could if you prove existence.
Or you can trace the malfeasance back to the agent.
That's the important part, especially in supply chain, right? So you can trace the transaction, and it may have been that the content that was put in was wrong. These pigs are healthy. This is good. But you can then walk it back and say, here's where the unhealthy pigs or whatever the content was came from.
Yes.
But what you can do is validate that all of the handoffs that happened, because that's publicly visible and mathematically signed, that says it went from A to B to C. And by the way, when it was put in A, they made a mistake in the content versus the package that it was wrapped in or transported in.
So I think some of that, you could do with a database, but I think there's kind of a weird thing going on, which is sort of like back before the internet, two companies could set up a modem-to-modem communication. You could set up a modem-to-modem communication around the world. It's just people really didn't, or only very, very high level, only a small percentage actually did it. For whatever reasons, I don't know, economic reasons, the cost. So just one second. So, but then when the internet came about, it's like, oh, well, wait, it's really easy to set up that communication. We trust that communication. When I send a byte here, it actually gets there, so on and so forth. So now everyone uses that communication. I think the same thing's kind of happening with this global compute framework that is also storage, but also compute, that you can trust the code that goes in actually gets executed as you meant it to. And when it stores data, it stores it. It has a huge consensus distributed around the world. that it's really true. So you could do exactly the same thing with the database, just as you could have set up modem-to-modem communication, but nobody really did because it would have to be all these individual point-to-point communication, all these individual point-to-point negotiations and contracts, as opposed to, hey, there's just this thing, but like everybody get on the bus, right? It's all going there. That's just, to me, that seems what's.
Well, but it is, but.
So the kind of to tie back and to raise the level of abstraction for a moment, that's we're really touching on what the true advent of blockchain is. I know we talked about this 4 weeks ago at our presentation, Michael. The blockchain allows parties that don't necessarily trust each other completely, or that could have monkey business around the transactions, to better trust each other, right? So when you talk about a supply chain, you're talking about many parties along the lines. So it's not just tracking what happened, but it's also being able to say if there was a bad transaction, where it happened exactly, through cryptographic signing. So then,
and just sort of use it out of the box, as opposed
that's
to.
right. So
yes, they could go and set up that negotiation with
you
each
could
one
build
themselves, but
you could build something on Oracle or SQL Server or other
and
technology.
even sign each other.
Exactly. So all that stuff could be done. So what the primary advance is the consensus algorithm between these untrusted nodes, and that is the primary innovation of blockchain.
And that's the part that I really get when we're talking about high-speed financial monetary transactions.
But all of
supply chain where it slows down and I'm shipping a container across the world and I have weeks and months to track it through the various hands. That's where it gets. And then there's
efficiency matters in every business. So what if that was more efficient? That there was less insurance overhead, that this is another domain, there was fewer chargebacks in the payment network than there are today in fraud. All of that's cost.
I want to interject at two levels.
Yeah.
So first of all, speed is not the issue. When I was pushing inside Microsoft the idea of doing BizTalk, they had I was one guy, and I was up against Office, who had a workflow technology, and I was up against SQL Server that had a workflow technology. I was up against Visual Studio that had a workflow technology, and I always asked them one question. Okay, so in the workflow between HP and Microsoft, who owns the database? Right, so yeah, you could set up, it's absolutely possible, you can set up that database. So are you going to set it up in Microsoft? And do you think that HP is going to be cool with that? Or are you going to set it up with inside HP and Microsoft's going to be cool with that? No. The speed is not the issue. The issue is the trust.
Right, so even between banks, domestically, internationally, it's the reconciliation, it's the accounting, it's the regulatory compliance, all those things are what drive the cost way up and why the banks are excited about blockchain.
Yeah, absolutely.
You could say it's primarily cost, but it's going to be lower cost because the trust is going to be higher.
And then to take the conversation up a level, this whole trust issue cuts across every sector. So one of the applications that I'm most excited about is a new kind of journalism. So imagine a journalism in which the journalists are incentivized to tell the truth, and the people who are receiving their content are incentivized to fact check, right? And the articles that get lots of fact checking behind it get promoted upward in your feed, and the articles that sort of suffer when it comes to fact checking begin to downgrade in your feed, right? Then this whole fake news phenomenon begins to shift. Yeah, so this trust issue crosses every sector.
Yep. So
that's a very good argument, but what happened to my
Yes, yeah, let's
go
ahead.
Basically, what they're saying is that it's just how we organize the information. Like the way that supply chains currently work is based on an old model, and people have to come through all these agreements in order to make that supply chain work. You could have completely different parties that never had any communication with each other have a supply chain from basically nothing started like that.
Yeah.
Because they don't trust each other.
Plus in standard also, right? So if you look at one company using CRM or another company using, some legacy software, right? So with blockchain, all the benefit is coming to standard. You have a smart contract and everybody's following the same language, right? That brings that efficiency. I mean, trust part, like what Greg said, that HP versus Microsoft. I mean, there are a number of ways you can sort it out. And US, our legal system is so strong. I think one of the best in the world. I don't know if you need blockchain in every situation, but I was talking to him while driving with Michael. So we need, if you look at our legal system, the way our language works, we use typical natural language the way you speak, right? And if you remember some of the past cases in the world, a comma made a big difference in the outcome of the legal case, right? The benefit of smart contracts taking out these kind of legal issues also, right? You have a one single language,
or exchanging one risk for another.
Yeah, no,
that's about it. Yeah, because then that gets back to the quality of how the contract was coded.
No, that's exactly. You're absolutely right about that.
Exactly.
There's no question. I mean, I was.
Thanks for coming.
Thank you so much. At the Sydney Koala conference, I was sitting with Lawrence Lessig, and he made a really interesting point about I can't remember the legal term for it. I think it was called acoustic separation. So imagine, and it was a fairly interesting physician paper that was apparently influential for a lot of lawmakers. So imagine that to one side you say one thing, and to another side you say another. So for example, to the court system you say, actually ignorance of the law is a pretty damn good excuse. But to the citizens you say, ignorance of the law, sorry, just no excuse. Right, so then when a case comes to court, right, you have incentivized the citizens to learn as much as they can of the law, but nobody's gonna be perfect. And then on the other side of that, a judge is gonna go, actually, I concede by all the depositions that you really didn't know what the situation was, and so that's a reasonable excuse. Okay, so in that kind of situation, what we can see is that there is a law of mercy. There's an understanding of mercy and compassion, and that is not going to be encoded in smart contracts, right? So we are always going to have a social fabric that is dialing and controlling these things.
Which makes me wonder, again, on the smart contracts themselves, is where's the tipping point in cost versus the application? In other words, let's go back to the attorneys. I've never received 100% solid contract from an attorney. It's always required at least a minimum of 5 touches.
Those damn attorneys.
At least.
There's a reason for that.
Lawyer full of flair. Yeah. So that's my point is you have, it's the idea that, give a man a watch, he knows the time, give a man 2 watches, he doesn't know anything. You get 2 attorneys, now it's got 5 touches on both sides. Add a third attorney to add as a neutral party, then they're red inking it as well, right? Yeah. And it'll take a while, but at some point you'll get a 99.9% fully baked agreement, and it's going to cost you a shit ton.
Yeah.
So my point is that if you take that concept and move it to the smart contracts, how many people are writing it? How many people are reviewing it? At what point do you know you have a fully baked item?
That is exactly what.
And then how much does it cost for the application of?
Yeah. But I think it's also remember not to overread the word contract in smart contract. It's just a program.
Yeah.
Okay, and it can be a poorly written program in any programming language.
I get the nuance.
Yeah. Well,
and same with the natural language also.
Well, but I mean, many people, right? They go right to the legalistic interpretation, right? That's you could do that in any program language. You could, for all time, say, hey, the database says this, so it must be true. Well, we're just moving up the bar a bit, a fair bit with blockchain, and a bit further with a better smart contract programming language, better programming language. But it doesn't remove the need for mercy, for interpretation, for things outside of the software.
But there are efficiencies in software development practices that are
Absolutely.
that are awesome compared to
Absolutely.
writing words.
Right.
I mean,
Yeah.
no software developer today doesn't grab tons of libraries that they've never looked at the code
And trust them.
and
Yeah.
trust them, pull
Yeah.
them in, build,
Yeah.
assemble them.
Yep.
And I know that happens in the law too with templates and so on and so forth. But boy, in software, you're using millions of lines
Yep.
of code.
Yep.
Hundreds of thousands
you
of
don't know.
hours of shared work that you've never, you've never.
Charles.
The important thing about this whole sort of argument about smart contracts and legal contracts is that a smart contract is neither smart nor a contract.
Yep.
What? This is why they call it smart contract.
That is pretty
smart. Legal contracts bake into them a lot of things that aren't in the document. Right? That, like, some agreement is so ridiculous that we're just not going to enforce it, right? Meanings of words that aren't necessarily, like in a program, you write everything from start to finish. It's got to be in the program or it's not going to do it.
And you know the behavior, right? You know the outcome except bugs, right?
Most of the cases, most of the
Okay,
cases,
let's change topics.
Yeah.
All right, Charles, please.
Frank, I know you've been working in Casper. Do Ethereum and Rchain end up with the same proof-of-stake consensus?
Not really. No, no, actually, no, I see that.
How?
I know, I see that actually as healthy.
What's different?
So one of the major differences is that you can kind of think of our blocks as programmable blocks. We don't actually, and that was one of the points I was trying to make in the presentation about, block size is 1. So our blocks are actually rule descriptions about what gets in and what doesn't. And then when validators are making block proposals, what they're really proposing are rules for what gets in and what doesn't. And then the algorithm checks to see if there's any conflict amongst those rules. If there's no conflict, no big deal. We don't have to run the Casper, right? We don't care. And that's the way most transactions are.
So how will it work in Ethereum?
So Ethereum has a very, very rigid control over block size and block time, so that there's a kind of a block tick, so to speak. And so that's their game for the foreseeable future. And we don't think that that's a scalable game.
So Ethereum's going to run is it Byzantine fault tolerant algorithm 1 out of every 100 blocks or something like that?
Something like that.
Something like that.
Yeah.
That's a day.
Yeah, so but that's their first intention for, is it the Metropolis release, right?
Yeah.
That's next. So they're taking a big step, but it's not whole hog moving from proof of work to proof of stake. And I guess I wanted to tie in this other conversation. Again, what I said before was that the big advantage of blockchain is consensus that allows what would otherwise be untrusting parties to better trust in a common system. And so that's consensus. Consensus with proof of work is horribly inefficient. And that's why everyone many people that believe proof of stake is possible, many people don't, by the way, is proof of stake will not only be more efficient, but it will allow broader participation, which is also.
How does it allow broader
So proof of work or mining using right now is really a commercial industrial kind of data center process. Most of it is in China where electricity is highly subsidized. A lot of it's in central Washington and Iceland and okay. Well, so but I remember a year and a half ago, the 8 largest mining heads of those operations were all on a panel, right? And it's just like they controlled the Bitcoin network essentially, them plus a few core developers. So that's fairly centralized, really, when it comes to.
So how is proof of stake more participants?
So they, I mean, there's still going to be machines that are favored, but it's going to be more general processors or GPUs and not the specialized mining equipment. That's all they're doing is SHA-256 on these ASICs and very electricity. And then also the in addition to that part of the hardware, if you will, the game theory that's applying to the Bitcoin consensus proof of work and the game theory that's applying to Casper are much different. And Greg, feel free to elaborate on that.
Well, in particular, remember when I talked about the justifications that are attached to messages that are in the Casper protocol. That whole idea actually came from Abramsky-Highland game theory, which is a different branch of game theory than the typical Nash von Neumann game theory. And it's a game theory that's directly related to the semantics of programs. So in the Abramsky-Highland games, which by the way was the first notion of games to solve a 25-year-old open problem, which had to do with the semantics of certain kinds of functional programs. The requirement to have these justification pointers is essentially what gave a notion of single-threadedness that turns out to solve this other issue of how do you say when a validator is equivocating. So that helps.
Thank you. Yeah, and I mean, the other thing to mention about Casper as well is that not everything needs to go through a full vetting cycle. When there are no conflicts within a given namespace for, say, transaction A is from Alice to Bob, and the second transaction is from Carol to Dave, right? Those transactions are not involving the same money. It's not a double spend. There's no conflict, so it doesn't have to go through a vetting cycle. And they don't have to be sequentialized even, where Bitcoin and Ethereum, every transaction globally needs to be sequentially and goes through this consensus algorithm that's proof of work.
So at least with respect to the Rchain version of Casper, which is wholly married to the notion of namespacing and the whole row calculus idea, you can have a whole sub namespace of validators that were stood up by a bunch of college students.
And what do I have to do to set up a validator?
You will learn that when Mercury comes out. Absolutely.
So you're working on that.
So, well, no, I mean we have a pretty clear idea.
But conceptually, I run some code and I put some assets, some tokens behind it.
That's correct. That's it. Yeah. So you start up a node. You start up a node, and that node for that namespace has got to have a Genesis block of validators, right? And then to be able to participate, either you're in the Genesis block or you have to go through a bonding period. Right? So that's the rough outline. There's a lot more to it than that, but
yeah. And another aspect just to drive home the scalability, and again, there's several things that make Rchain scalable. But an additional thing we haven't talked about explicitly is that not every node needs to run every namespace. So you stand up a node, and the node you declare to say, I care about these 5 namespaces, not the other hundreds of thousands of namespaces. And so then that node will connect to other nodes that care about those same namespaces. And so transactions of Alice to Bob and Carol to Dave may not even be validated on the same node.
Yeah, and it's actually super important, right? I mean, everybody knows the pain of syncing the blockchain. Like if you've had to do that for yourself, this is a serious pain. I mean, it's quite interesting actually to go and talk to the exchanges. We were just talking with Bill from Bitrex, right? The exchanges are hiding,
masking
the terrible quality of the software at this point, right? I mean, they make it appear as if this software is responsive and stable and robust, and it's not. But if you are running this on your own local machines, you know this for a fact.
Navneet has spent days trying to get his blockchain to sync on Ethereum.
Just to pay the bills.
And
frequently,
and it's just
bills with cryptocurrency. I'm frequently in this.
He's not doing anything, and it's getting more and more full. So now I have to, I used to not worry about when my Ethereum and Mist and Geth clients were running. And now I have to sort of proactively run them, because when I have to pay a bill, it's like I don't want to spend for 6 hours to
Yeah.
catch up, you know?
And so the point of
Yeah.
namespacing is to begin to address that. It's absolutely insane.
Yeah.
And it may come to, you could imagine a point in the not too distant future with respect to the proof of work style blockchains or ones that are not scalable enough that you can never catch up, right? You know, you just don't have the processing power to catch up and sync, right?
And verify also.
Yeah, exactly. So
So-
that's a terrible position to be in. But if you're interested in these 5 namespaces, then you can catch up.
Yeah. So one more question, and I want to. Please.
Go ahead, yeah.
Yeah, so I was just thinking about validators and consensus, and I'm thinking about blockchain use cases as used in terms of more information flow, information sharing, or asset sharing, right?
Yep.
So if you think about these 2 different types of blockchains, if you will, where do you think validators are really required versus not? You know, is it only required when the asset comes into play because there's a physical thing that's moving and, or not actually?
No, you actually need it in the case of information, because what the validators are doing is they're playing by a particular set of rules so that nobody's in charge, but everybody agrees on what the data is on that validator set.
Okay.
I mean, if you have a completely centralized process, let's say you're the New York Times and everything goes to the editorial desk before it gets published. That's a centralized process, right? And blockchain is not going to particularly help you with your publishing process.
Yeah.
Okay, but if you're talking about a new type of publication where articles are coming from everywhere and the provenance matters and who gets compensated matters, that now you have both a content problem, right, as well as a payment problem. And so there are a lot of these use cases that are content and payment, or content asset control. So,
which is true not only of journalism, but it's also true of science, right? And we're seeing this massive shift in the way scientific articles are published, right? And again, there's this whole trust issue. Do you trust that this article has been vetted? Do you trust that the data sets that they utilize were correct? Do you trust that the models they utilize were correct? This cuts across every swath.
So before the research publication is done, everyone kind of starts commenting on it and starts kind of, the provenance keeps improving.
Exactly.
And only when the scientific community across the world, let's say, to be kind of really realistic, agrees that this is true and validated, that's when it gets published.
yeah, and it's got a higher reputation.
Yeah, that's exactly right.
And the reference also, right? Meaning you can
Exactly.
other old papers and then they are.
So I want to shift focus a bit. Let's talk about some of the accomplishments we've had in the past few months, and then what we are planning in the next few months, and then finally, how can people get involved and learn more about Rchain, and then we can turn back to more of an informal Q&A. Let's at least cover some of those.
Yeah, so I mean, there's been so much. One of the things that's been really exciting for me is the solidification of the mathematical description of the ladle algorithm. So we haven't talked at all about the ladle algorithm, but it's called ladle because it's an acronym for logic as a distributed law. And what the ladle algorithm does is it's very general purpose. You hand me a rewrite system and a way to collect results, whether it's in a list or a bag or a set or whatever, right? And I will hand you back to that system.
What's a rewrite system?
So glad you asked. So examples of rewrite systems include virtual machines. They include programming language specifications, and a host of other kinds of things. But those top 2 should be quite interesting to you. So what this does is it allows us, for example, if you hand me a description of JavaScript and a way to collect the results, I can give you a type system for JavaScript. If you hand me a description of the Ethereum virtual machine and a way to collect the results, I can hand you back a type system for the Ethereum virtual machine.
And it has one, right?
The Ethereum virtual machine?
Yeah.
What? I wish.
Oh, but Solidity does.
Sort of. No, those, and one of the interesting points that Ed is making is that the kind of types that we generate are not just types. The way I like to describe them is when you plug wires like this together, yeah, So there's a spec for how these endpoints plug together, right? But now if we think about opening up, so types in ordinary programming languages are like this. They spec out how the input and outputs have to play together. Now, there's another kind of type that you can imagine. Imagine we open up this box here, this physical box, and we look at the motherboard. And we think about replacing components. And we're not just concerned with what goes across the pins. We're concerned that what we put in here is actually a CPU and not a GPU, right? Or what we put in here is a CPU and not some memory, right? So that kind of substitutability is a different kind of substitutability, and our types catch that.
Yeah, I'm thinking of Spencer over here, who's a computer science and mechanical engineering student at Wazoo, and yeah, this is exactly what we're talking about. It's like both in computer science, such as JavaScript, right? Doesn't quite have that behavior.
No. So those
Right.
I picked on JavaScript because it's a language that doesn't have a lot of types.
Yeah.
Type support. But if you look at the industry, it's actually worth thinking about, because Microsoft has a typed version, and that was laboriously hand-built. It cost tens, if not hundreds of millions of dollars to push that standard through. Google has a hand-built version of a typed JavaScript, right? And Facebook has a hand-built version of a typed JavaScript. Why? Because not typing doesn't really work in production. This algorithm completely obviates all of that. I mean, completely obviates all of that. You press a button and out comes a type system. Okay, so that's what's cool about this. And the reason it's important is because we're using it all throughout the whole Rchain architecture, right? So we're using it when we talked about the programmable blocks. So we're using the ladle algorithm to describe that language of rules for what gets into a block and what doesn't get into a block. And we use it to check the compatibility of rule sets. So that's what that algorithm is doing for us, right? So that's one. We also use it to generate the type system for row length. Now, where's the value in that? Well, let's talk about, I don't know, the DAO bug. And more recently, the parity bug. So our type system catches errors like that. In fact, we published a paper last year showing that if you just had written the same contract in Rowlang, the type system would have caught the bug. So your contract wouldn't have compiled, much less been checked in and deployed.
Yeah, so this is part of the we're based in the semantics and mathematics of mobile processes and that are provably correct in that domain. We're making as correct by construction transformation into the software, and that's what's running ultimately on the virtual machine. And to be able to know that every step of the way is mathematically and model sound, and this ladle algorithm allows that correct by construction approach in many of these algorithms. So that's how this all ties together and why it's important.
So that's one. Two, the Rowlang spec has gotten much more mature because we've beaten on it to the point where we can write down an ERC20 contract. And it was nice because we all came together with lots of different points of view, right? I wouldn't have cared if the contract was, half again as long as the Solidity contract. But, one of my developers really cared about that. And so we adjusted some of the language features so that he could have that compressed expression.
And the other aspect was to be consistent syntactically, where some people may have what's an adornment and sugaring of a language that they're familiar with from their background, and others have their favorites. But if it can be more consistent, it'll be more easily taught.
Oh, absolutely. So one of the things that's been so satisfying and gratifying, we were looking at just how the collections, like every programming language needs data types that are associated with things like lists or trees or that kind of thing. And we wanted to make sure that had a good support or basis within the language. And the people that were concerned about that, we could discuss by writing equations. I mean, literally, the conversation in the design of this aspect of the language was, here are 3 equations that every design must support. And then each proposal was vetted just by first just show me you support these equations. And then we could calculate and see whether or not those equations were true of the proposals for the designs. So this to me is very exciting and gratifying because it means it's a completely different quality of offering than we are used to seeing, say, from in our browser like JavaScript.
Now, to be fair to Brendan,
I mean, he did a great thing.
And he apologized for it publicly multiple times. So Brendan Ike is now leading a blockchain inspired browser called the Brave browser. And he's familiar with process or PyCalculus and others, and we're going to connect up with him. So yeah,
I think he's learned his lesson.
He's learned his lesson. Yeah, exactly. That's fine. So let's go a little bit faster through some of these other accomplishments. We've got additional team members.
Yeah, yeah. So we actually just signed a contract with one of our star developers, Kent, who was the guy who did who took the compiler that I started and brought it all the way to the level of maturity that it is now.
Awesome. And Chris has started fairly recently. Welcome, Chris. So we ramped up an additional developer and a half on the holding/lively gig side to work on wallet software. And there's since again our last meeting was end of April, so there's quite a bit of progress.
We've been executing quite well with a group called Pyrofex. So this one of the principals is my longtime collaborator Mike Stay on the Ladle algorithm, who is not only an expert in category theory, he's also an expert in cryptography. So we're very happy to be working with Pyrofex, and they're going to be driving the developer tools story. So we just completed that agreement with them, which is really awesome. And let's see what else is going on.
We've had successes on fundraising on Rchain Holdings, which has allowed some of this growth on Rchain Holdings, and worked out some of the wallet design issues and moving forward on that. We've also had some new team. Glenn is fairly new, and Brandon is new, and Shingai is fairly new. Lawrence is fairly new, so we're accelerating our team. And then, so now looking forward for the next few months, do you want to talk about the fundraising?
Yeah,
plans?
so basically every day someone comes to me and says, how can I buy rocks? And
What are rocks?
Oh,
Sorry.
So that's a long discussion, but let me just say that in order to help those people who initially invested in Scenario to support Rchain, we've created a mechanism whereby they could just directly support Rchain. And that's what the ROX tokens are. The ROX tokens will eventually be swappable for the Rev, which runs directly on Rchain. Right now, ROX tokens run on the Ethereum network. So every day someone comes to me saying, I really want to buy ROX because I really want to support this project. And I've basically had to say, there's too many of you, I can't deal with this and build the Rchain. So we've got a group called Coin Fund, which is helping to organize a private sale for those people who want to get involved. There, we're going to keep it a private sale, and the reason we're going to keep it a private sale is because we really, really want KYC. We really, really need to know who's going to be engaged at the level. We want to make sure that it's people who are serious about the project, right? We're less interested in those people who are just doing coin speculation. More interested in those people who have a long-term value-based alignment. So that's very, very much underway. There's a channel on our Slack, a private channel, so people who want to get engaged in that way, please contact me and I'll get you connected into that network and off into the Coin Fund. And all of the Coin Fund discussion and all of the due diligence documents that are associated with that are either have been pulled together or are under construction. There's a new white paper that I'm writing, which includes a lot of the material from this presentation here. And let's see, what else is there? I mean, it's like my brain explodes.
Yeah. So you know, we had this several months ago, but we have the work breakdown structure, which is the beginning of the project plan. We are loading that up into Jira for more of an agile project management. We have project manager coming on board within a week or two that will help organize that, and we're continuing to hire as funding allows on the platform. So in addition to the language and the compiler and Rovium, we're going to re-implement the older Rosette VM into a Scala VM, and then that will enable some additional library access and delimited continuation improvements. We still need to build out the COM layer and for peer-to-peer communications as well as the database structure. So neither of those are particularly groundbreaking for Rchain, but it is important that they are fairly self-contained and don't bring in a lot of external dependencies.
Yeah, that's right.
And that they're supportable in this context.
Right, because one of the things that was so difficult when we were deploying the early scenario nodes was we had so many moving parts that the deployment of the technology was challenging.
Right.
So we're trying to put a container around that, not just a Docker container, but a sort of a container of discipline around.
Right. And then the next major milestone after the new execution environment compiler comms in database is implementing Casper, which is very far along in the design, but once it can be programmed in Rolang with the distributed database, not the database and peer-to-peer, then we can demonstrate consensus working, and that will be a major milestone.
Yeah.
So that's roughly the platform roadmap. And on the
there's a couple of other points, right? So one is we're also working with a group out of the University of Illinois called the K Framework Group, and they have both an academic presence and an industrial presence. The principle behind that is Grigori Rosu, and effectively what it allows you to do is write down rewrite systems. So there are specs for Java, JavaScript, Haskell, OCaml, the EVM, a bunch of things like that that already have been tested within the K framework. And what we've done right now is to write up. We've done versions of the subsets of the row calculus in K framework to test the K framework actually does what it claims it does. And then we're going to give back to K framework. We're going to add the ladle algorithm to K framework. The other thing that we've been doing with Vlad is to show that Vlad's version of Casper scales to arbitrary rewrite systems. So Kent and Vlad and Mike and I met over a period of time, about a month and a half ago, to show that there's nothing blockchain specific about Vlad's approach to Casper. So this is very exciting, and this is a thought I would love to leave you with as you walk out the door. Okay? So in a matter of 3 to 5 years, you will be able to take a technology like K Framework and press a button and take the spec that you just wrote down for your favorite language or your favorite virtual machine and replicate it. Meaning you will suddenly have a Casper-driven version of your semantics that executes in a completely decentralized and distributed fashion. Okay? So press a button, and so the platform part of the whole blockchain space is going to be commoditized. Going to be commoditized. In addition, those things that you wrote down, you press a button and they get a type system. So you get, for free, on open source code, typed, decentralized, distributed versions of your favorite VM or language. That means that the value prop in the platform in the next 3 to 5 years does that. 0. Very fast. Okay, so where's the value? The value is in the apps. Supply chain management, the new kind of journalism, and in a whole bunch of other things.
Social networks that establish the trust relationships that establish the KYC with real entities trusting each other around it, those kinds of things. Yeah. So I think we should, well, just let me wrap up by how can you get involved? How can you learn more about Rchain? first of all, our two websites are rchain.coop for the cooperative and rchain.io for the holdings company. And you can find us both ways. They have pointers to the architecture document, to how to join the Slack channel. There's many specific channels in Slack around the tech or particular application areas. And ask questions there. We're happy to respond, or PM either of us at Lighthouse or at ed.io on Slack. And then also, if you have additional ideas, please bring them to us. We'd love to talk through that. Also, we're intending to have a blockchain hackathon with an Rchain bent to probably in the November timeframe. Do you want to talk about that a little bit, Philip?
Sure. Yeah, so in the interest of putting scale on applications, we would invite teams to cross-functional teams to come and bring their diversity of thought on what the applications could possibly be. So yeah, we're thinking late fall, early November for that, or early winter for that. So
right, and Seattle's a bit behind in terms of blockchain thinking and adoption. If you go to Berlin, to New York, to London, to South Korea, to Japan, and Shanghai, they are all ahead. Obviously, the Bay Area, but there's no reason we have to stay behind at all. So I certainly have part of my mission is to grow a community around Rchain, specifically in Seattle. We won't limit ourselves to Seattle, but we have businesses here that certainly could benefit in a great way, and some are already into blockchain now. They're a bit quiet about what they're doing. But so with that, let's wrap up. Thank you to all. You're welcome to hang out, and please do. If you haven't met each other, please exchange business cards and say hi to each other at minimum. Thanks very much. Thanks, Greg.